subscribe now and press the bell icon. Never miss an update.
Hi friends, myself Dr. Darsanjani, and today we learn about most important topic of chemistry, that is multi-component reaction. Also, don't miss to like and share the video, subscribe the channel Chemistry Online by Dr. Darsanjani, and also hit the bell icon to get notification for such important videos, right? So let me start our most important topic, that is multi-component reaction. So first of all, we should know about, friends, what is multi-component reaction, or what is the definition of multi-component reaction. So we can define the term multi-component reaction in single line as two or more reactant are combined sequentially to give a selective product is known as multi-component reaction. Now we should also know about the application of multi-component reaction. So which are the important applications of multi-component reaction? So when we are using multi-component reaction, what will happen? The number of steps will be reduced, right? So this is the most important application of MCR. And the next one is process waste will be reduced when we are using MCR. So these are the applications of multi-component reaction. Now let me start our first multi-component reaction, that is UG reaction. As we can see on the board that UG reaction is a 4-component condensation. As we can say that it is a 4-component condensation. Which are that 4 reactant or component? So it can be defined as aldehyde, amine, carboxylic acid and isocyanide are combined with each other to give alpha amino acylamide derivative. Then such process or reaction is known as UG reaction. So first and important application of UG reaction, that is, it is important to generate libraries for screening purpose, right? When we want to generate a libraries for screening purpose, then it can be easily carried out with the help of UG reaction. Now friends, we see here the reaction, right? So first of all, what will happen? Aldehyde and amine are combined to give imine derivatives, right? Then what will happen? This imine will react with isocyanide and acid component. After loss of water molecule, it will give alpha amino acylamide derivatives. Why this is a 4-component condensation? So as we can see here that there is a loss of water molecule, therefore this reaction is known as 4-component condensation. Now why this is called alpha amino acylamide? So it can be defined as the next position to the carbonyl is known as alpha, as we know that. Now what will happen? Alpha amino, as we know that this amine group is attached to the alpha position, right? So this is alpha amino acyl. We know this group is known as acyl group. So alpha amino acyl amide derivatives. Therefore this product is known as alpha amino acylamide derivatives. Now we think about a mechanism of this UG reaction, then it can be defined as when this aldehyde and amine group are combined with each other to give imine derivatives, or we can also say that imine intermediate. Now what will happen? This imine intermediate is react with acid. How? Let's see here. The proton of acid is attached to the nitrogen of imine to give positively charged species and gives acetate ion. Now what will happen, friends? Here this intermediate positively charged species is react with isocyanide group. As we know that in isocyanide, nitrogen having partial positive charge, so it will generate partial negative charge on carbon of isocyanide. Now what will happen, this negatively charged carbon of isocyanide will attack over this carbon of positively charged species. So what will happen, this pi bonding electron will be shifted over nitrogen to satisfy the charge of nitrogen, and we will get such type of intermediate. In next step, what will happen, this negatively charged oxygen of acetate will attack over carbon of isocyanide, due to which this pi bonding electron will be shifted over nitrogen to satisfy the charge of nitrogen, and we will get such type of intermediate. Now in next step, what will happen, this hydrogen which is attached to the nitrogen is lost in form of H plus. So what happened, this bonding pair of electron will be shifted over nitrogen here. The lone pair of nitrogen will attack over carbonyl carbon. As we know that the carbonyl carbon having partial positive charge, this bonding pair between carbonyl carbon and oxygen is shifted between carbon and oxygen, this one, right? And what will happen, this pi bonding electron will be shifted over nitrogen. So nitrogen will get partial or negative charge, right? So this hydrogen may attach this nitrogen, and we will get our desired product, that is alpha amino acylamide derivatives. As we know that, or as we define here, why it is called alpha amino acylamide derivatives. So guys, by this way we can easily define the most important MCR, multi-component reaction, that is UG reaction. Next important multi-component reaction is Bigenary reaction. So what is Bigenary reaction? So it is actually a 3-component acid catalyzed reaction of aldehyde, urea and beta keto ester. So in ethanol as a solvent, in acidic media, it will give dihydropyrimidine as a product. Then such reaction is known as Bigenary reaction. How? Let's see with the help of example and mechanism, that when beta keto ester is react with aldehyde and urea in ethanol as a solvent, in acidic media it will give dihydropyrimidine as a product. Then such reaction is known as Bigenary reaction. Now what about mechanism? So in mechanism, when aldehyde is react with urea, then what will happen, here we know that there is a lone pair on nitrogen of urea. So one hydrogen will lose, bonding pair will be shifted towards nitrogen, and lone pair of nitrogen will attach over carbonyl carbon of aldehyde. So we will get such type of intermediate species. Now what will happen, in acidic media, the lone pair of oxygen will attach this proton, right? And water molecule will lose, and this bonding pair will be shifted between carbon and NH. So what will happen, we will get this iminium electrophile. Now in next step, what will happen, this beta keto ester will lose proton in form of H plus and added as a nucleophile to this iminium electrophile to give such type of cyclic product. And again we know that the hydrogen will lose in form of minus H plus, right? This bonding pair will be shifted over nitrogen. The lone pair of nitrogen will attach over or attack over carbonyl carbon, and this pi bonding electron will be shifted over oxygen, and this H may attach there, and there is a loss of OH and hydrogen from the next carbon to get this dihydropyrimidines as a product. So this reaction is known as Bigenary reaction. Now in next important reaction, that is Pasterini reaction. So first of all, we should know that what is Pasterini reaction, right? So in Pasterini reaction, it is a 3-component condensation of isocyanide, carbonyl compound and acid to give alpha acyloxy carboxamide as a product. Then such reaction is known as Pasterini reaction. Now, which are the favorable conditions for this Pasterini reaction? So we can say that aprotic solvent is most favorable for this Pasterini reaction. Then as we increase the concentration of reactant or component, then the yield of the reaction will be increases. And last but not the least, that H bonding play a crucial role rather than ionic pathway. And from the mechanism we can prove this statement, as in mechanism we can see that this carbonyl compound react with acid. So what will happen here? We can see that H transfer will takes place from acid to ketone. So we will get such type of compound, right? Here simply that hydrogen of acid is attached to the lone pair of oxygen of carbonyl compound. Now what will happen? As we know, in isocyanide, nitrogen having partial positive charge and carbon having partial negative charge. So what will happen? This negatively charged carbon will attach over this carbonyl carbon. So this pi bonding electron will be shifted over oxygen to satisfy the charge of oxygen. In next step, what will happen? This acetate ion will attack over the carbon of isocyanide, and pi bonding electron will be shifted over nitrogen to satisfy the charge of nitrogen, and we will get such type of intermediate species. Now in next step, what will happen? This hydrogen will lose in form of H plus. This bonding pair will be shifted over oxygen. The lone pair of oxygen will attack over carbonyl carbon. This bonding electron will be shifted between this and this carbon and oxygen, and this pi bonding electron will be shifted over nitrogen, and this hydrogen may attach this nitrogen. So we will get our desired product, that is alpha acyloxy carboxamide. Now why this product is known as alpha acyloxy carboxamide? So we can see here that, as we discussed in earlier lecture, that position next to carbonyl is known as alpha. Then this one is acyl, this oxy. So alpha acyl oxy carboxamide, right? So by this way, this product of Pasterini reaction is known as alpha acyloxy carboxamide product. Next important multi-component reaction, that is Hence dihydropyridine or pyridine synthesis. How it is carried out? So when one molecules of aldehyde or carbonyl compound react with 2 moles of beta ketoester in presence of ammonia, then we get dihydropyridine as a product. Then such reaction is known as Hence dihydropyridine synthesis. How? Let's see with the help of reaction and mechanism. As we can see here that 1 molecules of aldehyde and 2 molecules of beta ketoester react in presence of ammonia to give dihydropyridine, or we can also say that substituted dihydropyridine as a product. Now in next step, what will happen? This intermediate is oxidized in presence of nitric acid, and then after followed by decarboxylation in presence of base to give our desired product, that is substituted pyridine. Now this reaction can be further explained with the help of mechanism. Let's see the mechanism. So mechanism of hence dihydropyridine synthesis is basically divided into two parts. We can memorize this mechanism with the help of these two important parts, that is aldol condensation and Michael addition. So friends, first of all we should know that what is aldol condensation. So as we earlier learned that when enolate or enol is react with carbonyl compound to give alpha beta unsaturated carbonyl compound is known as aldol condensation. Now let's see here that base will react with 1 mole of beta ketoester to give enol, which is called enolate formation. How? This molecule of ammonia will abstract proton of enol form of this beta ketoester. So what will happen? This pi bonding this bonding pair will be shifted over here. This pi bonding electron will be shifted over this carbon in form of negative charge, and this negatively charged carbon will attach or attack over carbonyl compound to give this beta hydroxycarbonyl compound, which is called aldol condensation as we define in definition. Then what will happen? It will undergo loss of water molecule at alpha beta position to give alpha beta unsaturated carbonyl compound, which is our first intermediate. Now in next step, that is in Michael addition, what is carried out? So first of all we should know about definition of Michael addition. So Michael addition can be defined as nucleophilic addition of carbanion or nucleophile to alpha beta unsaturated carbonyl compound is known as Michael addition. How? Let's see in mechanism that this other molecule of beta ketoester is react with ammonia, or we can also say that the lone pair of nitrogen of ammonia will attack over carbonyl carbon to give such type of compound. Now why this step is carried out? For the formation of enamine. How? So there is this lone pair of nitrogen will transfer between this carbon and nitrogen bond, and this hydroxyl will lose in form of water, right? Now here there is one proton. So what will happen? The base will abstract such proton, this bonding pair will be shifted over here, and this pi bonding electron will satisfy the positive charge of nitrogen, and we will get our desired intermediate, that is enamine. Why it is called enamine? There is a alkene which is attached to amine, so it is known as enamine. Now in next step what will happen? This second intermediate will react with first intermediate. How? Let's see. So it is carried out by Michael addition, that is, as we define, this lone pair will be shifted over here, this pi bonding electron will be shifted over carbon to give carbanion. This carbanion will attack over alpha beta unsaturated carbonyl compound, which is known as Michael addition. After this Michael addition, what is carried out? This base will abstract proton from here, and this bonding electron will be shifted over here, and this pi bonding electron will be shifted over nitrogen in form of lone pair, and parallelly what will carried out? This negatively charged pair is shifted between carbon and oxygen, and this pi bonding electron will be shifted over this carbon, and it will abstract proton from base, right? So tautomerization will carried out, and we will get such type of species, or we can also say that intermediate species. Now what will happen? This lone pair of nitrogen is attached or attacked to carbonyl carbon, which will abstract proton and will undergo loss of proton by base, right? And so proton will removed from this carbon, and hydroxyl will remove from adjacent carbon to give unsaturated or double bond formation. So by this way we will get dihydropyridine as a product. And we know the two next step, right? Which are that? So first one is this compound will undergo oxidation with the help of nitric acid, and then after, in presence of base, it will undergo decarboxylation to give our desired product, that is substituted pyridine. So by this way we can easily memorize this hence dihydropyridine synthesis with the help of this mechanism and three easy steps. First one is aldol condensation by formation of enol or enolate. Then there is a formation of enamine, and which will undergo Michael addition to give our product. Next important reaction is Mannich reaction. As we can see on the board, that in Mannich reaction, what will carried out? Compound having at least one active hydrogen atom react or condenses with formaldehyde, primary amine, ammonia to gives Mannich base as a product. Then such reaction is known as Mannich reaction. How? Let's see here that compound having at least one active hydrogen combined with formaldehyde and primary or secondary amine or ammonia to gives Mannich base as a product. Then such reaction is known as Mannich reaction. Now when this Mannich base, here we can see that Mannich base, so we can eliminate this dimethyl ammonium chloride group by heating it. So we will get alpha beta unsaturated carbonyl as a product. And also if we want to replace this dimethyl ammonium chloride group, then it can be easily replaced by heating such Mannich base with Caesium, potassium cyanide. Now when we talk about mechanism of such Mannich reaction, then it will be mainly carried out in two steps, out of which first step is it involves the formation of methylene ammonium salt. Here we can see that methylene ammonium salt, and it will be react with either enol form of ketone or carbanion, which is generated by ketone. So here we can see that dimethyl ammonium chloride react with formaldehyde to gives such. First of all, what will happen? It will lose Cl minus as an ion. The one of the hydrogen of nitrogen is attached to the lone pair of oxygen, and oxygen will get positive charge. Now in next step, what will happen? The lone pair of nitrogen will attack over carbon, and this pi bonding electron will be shifted over oxygen to satisfy the charge of oxygen. So we will get such type of compound which will undergo loss of water molecule. As we can see here that hydrogen from nitrogen and OH or hydroxyl from CH2 will remove in form of water to gives dimethyl methylene ammonium salt 2. Clear? Then it will react with acetophenone or compound having at least one active hydrogen atom. What will happen? The enol form will lose proton. This bonding pair will be shifted between carbon and oxygen. This pi bonding electron will shifted over carbon, and carbon will get negative charge, or we can also say that carbanion derived from ketone. This carbanion will attack over CH2 group, and this pi bonding electron will satisfy the charge of nitrogen. So we will get such type of compound, right? Then what will happen? It will react with HCl to gives such compound, and by this way we will get our desired product, and this whole mechanism is known as Mannich reaction. So by this way we can easily memorize important multi-component reactions. So friends, we will talk about remaining multi-component reaction in our next lecture. Also, don't miss to share the video, like the video, and also subscribe the channel Chemistry Online by Dr. Darsanjani. Also share the video maximum, so maximum a student can take the benefit of such important videos. Hit the bell icon to get regular notification of such important videos. Thank you very much.